Today we're going to work on the law of cosines. Go ahead and pause the video and copy the law of cosines into your notes. The first example I'm going to do is three sides of a triangle. So cosines only applies to three sides of a triangle and side included angle side. So there are two types of problems that use the law of cosines. So three sides of a triangle. So I have my triangle drawn here for me. And I'm just going to go ahead and write the law in the form in which I need it. So cosine B, a squared plus c squared minus b squared over 2ac. All right, now I'm going to plug in everything from my triangle. So cosine B and cosine B equals negative 0.45089. All right, so now I'm going to use my inverse cosine button. So just to point this out, let me bring my calculator in here. Similar to what we did with sine here, the inverse cosine button is going to be second cosine. So I'm going to go ahead and go second cosine negative 45089. And that gives me angle B is 116.8 degrees. All right. This is an obtuse angle. And a triangle can only have one obtuse angle, right? So just to make ourselves feel better, just in case you're worried about it, we're going to go ahead and take 180 minus 116.8 and take the cosine of that. And that gives me positive 0.45089. So I know that that angle cannot exist in my triangle. All right, so now I need to move into solving the rest of my triangle. So I'm going to put 116.8 here just to keep track. Now it's actually easiest to use law of sines. So if you look, I've got angle B and side B. And I've got side A, so now I can find angle A. So I'll do that over here. Sine A for A equals sine B over B. Fill in my values. So I don't know what sine A is. Okay, so that's going to end up being sine A equals 8 times sine 116.8 over 19. Okay, and then when I plug it into the calculator, I get A equals 22.1 degrees. So A is 22.1 degrees. All right, now to find angle C, I'm going to subtract from 180. So here's my work for finding angle C. 180 minus 22.1 minus, running out of room here, 116.8. And so angle C is going to be 41.1 degrees. Let me go ahead and keep track. track of my answers here. And there I have all of my angles for the triangle where I started with 3 sides. Okay. Next, I'm going to do 2 sides and the included angle. So notice I have side B and side C, and I have the angle in between them at 25 degrees. All right, so we're going to use the law of cosines to find side A. So I'm going to go ahead and use the law that is, or use the arrangement of the law that is easiest for me. Not because the other one won't work, but because why not? Why not save myself some work? Why not save ourselves some work? So let's go ahead and fill this in. And so a squared equals about 29.2375, which then means a equals 5.4072. And it bears mentioning here that usually when we take the root, it's plus or minus, but in this case we're talking about a distance, and we're going to use just the positive number. So a equals 5.4. Okay, so now we have a ratio between angle A and side A. So now we can flip back to the law of sines. So sine A over side A. And then I'm going to compare it to B. So I'm going to have sine B, which I don't know, over side B. So I'm going to fill in my values here. Okay. So I'm solving for B here. So I end up with sine B equals 0.7034, which means B equals 44.7 degrees. All right, now we have an acute angle, and I need to double check and see if there are actually 2 angles under 180 degrees that have the same sign. So I'm going to take 180 minus 44.7, and that's going to give me 135.3. All right, and so I'm going to double check just the good old-fashioned way. So I'm going to go here in my calculator, and I'm just going to type it in and see if it gives me this same sine value. So sine of 135.3, and there I have the exact same sine value. So this is definitely double check foul proof. This now means that I have 2 triangles. I have one triangle where B is an acute angle, and I have one triangle where B is the obtuse angle. So just to give us a visual here, this B value would be what the triangle up here looks like. This B value, let's see if I can, okay, would be what this triangle looks like. So I've got the 135.3, the 25, and then this third angle, which I'm about to find. So let me just label this. And I definitely need that 5.4 too long. Make it a little bit better there. Okay. And now the only thing I have to do is find angle C. So I'm going to subtract from 180. So for this triangle over here, angle C is going to equal 180 minus 44.7 minus 25. So that's going to be 110.3 degrees. And then for this triangle over here, it's going to be C equals 180 minus 135.3 degrees minus 25 degrees. And so this one, C equals 19.7. And then we just have to use a little bit of logic and reasoning here. So let me go ahead and get a highlighter. All right, so these are our two possibilities. Now we're going to look back. Let me fill this in. Now we're going to look back at both of the triangles we've created. And remember, the sides are proportional. So the longest side must correspond to the biggest angle. So if I look down here, the longest side does not correspond to the biggest angle. So this is not the correct solution because this doesn't make sense. It doesn't follow the ratio rules. So I do have to find both of these solutions, but then I have to determine which is actually correct. So what is actually correct for this is this one right here. So angle C is 110.3 degrees. Angle B is 44.7 degrees. Angle A was given. So my final answers would be angle C equals 110.3 degrees. Angle B equals 44.7 degrees, and A equals 5.4.